going to begin looking at polynomials, and first of all we're going to see how we can add and subtract polynomials, but before we do that, let's define a polynomial. A polynomial is a monomial, which we've seen before, a monomial. Remember, a monomial cannot have variables in the denominator. It can be a constant. A polynomial is a monomial, or the sum or difference of monomials. Some polynomials have special names. A binomial has two terms. For instance, x plus 2y is a binomial with two terms. It has a term of x, it has the term of 2y. A trinomial it's the sum of three monomials. In other words, x squared plus 2x plus 1 is a trinomial. It has three terms. Now, it doesn't matter whether I'm adding or subtracting. Just as a general rule, we say the sum of monomials, but we could have some subtraction in there. We want to look at the degree of a monomial. The degree of a monomial. The degree of a monomial is the sum of the exponents of all of its variables. It's the sum of the exponents. Let me erase that. The sum of the exponents of its variables. So let's look at a few monomials and see if we can determine what the degree of each of those monomials is. If I had x cubed y squared z, and we wanted to determine the degree of this monomial, well, we have, remember, if there is no exponent showing, a 1 is understood to be there. So if we want to get the degree of this monomial, it's 3 plus 2 plus 1, so this has a degree of 3. If we had 4xy, we have exponents of 1 and 1, so this has a degree of 2. So to get the degree of a monomial, we simply add the degree of each exponent together, and that gives us the degree of that monomial. Now, to get the degree of a polynomial, remember we said a polynomial could be a monomial or the sum of monomials. To get the degree of a polynomial, it is the greatest degree of any term in that polynomial. It's the greatest degree of any term. Of the polynomial. And I'm going to abbreviate polynomial this way just to save some time. So for instance, if I had x to the 4th plus 6x to the 5th plus 7y, the degree of this polynomial is 5. And if I were to put this in standard form, then what we would do is rewrite this so that the highest degree is first and we go down in order. So since we have, this would be your standard form, 6x to the 5th plus x to the fourth plus 7y. Notice we start with the highest degree and we go down in descending order. And this y is a different variable, but that's the only one with the y, so we'll just put that one last. This is degree 5. The leading coefficient is 6. The coefficient is the number in front of the variable. The leading coefficient of this, I can't spell today, the leading coefficient, we have another polynomial, negative 3y squared minus 2y plus 6y cubed. The degree here is 3 because that is the highest exponent. If we put this in standard form, we've got to put the 6y cubed term first, minus 3y squared, minus 2y. Remember, this is a trinomial because it has 3 parts. The leading coefficient is, again, 6. The leading coefficient is the coefficient or the constant that goes with the highest degree term, so the leading coefficient of 6. Now, when we talk about the degree of a polynomial, some of them have a name. If we have a degree of 0, then that's a constant. If we have a degree of 1, that's called a linear polynomial. You worked with linear equations, and the graph of a linear equation, remember, was a line. If we have a degree of 2, that is called a quadratic. A quadratic. And we will be looking at quadratic equations before too much longer. A degree of 3 is a cubic polynomial. A degree of 4 is a quartic, which you don't see that term real often. You might just call it a 4th degree or a quartic. But if you have a degree of 0, you always have a constant. If we have a degree of 1, it's linear. A degree of 2 is quadratic. A degree of 3 is cubic. And a degree of 4 is quartic. You may or may not hear that term a whole lot, but you will see these terms a whole lot in your future journeys in mathematics. So let's look at some expressions and determine, first of all, whether we have a polynomial, what its degree is, and what kind of polynomial we have, whether we have a monomial, a binomial, a trinomial. So let's just look at some expressions and see what we can determine. I have some terms here. We want to look at this first term, 5rx plus 7tuv. First of all, is this a polynomial? And we can see that yes, it is. It is a binomial. That's the type of polynomial that it is because we have 2 terms. The degree of this binomial is, well, we have a 1 and a 1 here, so the degree of that term is 2. The degree of this term is 3, so the degree of this binomial is 3. What about x? That is a monomial, and the degree is 1. What about 10x to the negative 4 minus 8xa? This is not a polynomial. Hopefully you recognized that x to the negative 4 puts a variable in the denominator, so this is not a polynomial. And then if we look at negative 12, yes, this is a monomial. Its degree is 0, And we just, that's just a constant. A constant has a degree of 0, and it is considered to be a monomial. Okay, here we have another polynomial. I want to put this polynomial in standard form and determine the leading coefficient. Notice this is a polynomial of degree 4 because that's our highest exponent, and that's the first term. To put it in standard form, 4x to the 4th minus the next term would be 2x squared because we go in descending order of exponents, minus 3x plus 8, and the leading coefficient is 4. Let's look at another one. 12 plus 5y plus 6xy plus 8xy squared. Now notice here, the highest degree is 3. So that's our first term, 8xy squared plus, now the next degree would be, has a degree of 2 plus 6xy plus 5y, which has a degree of 1, plus 12, which has a degree of 0. Now, because it would be as if you had an x to the 0. That's why we say a degree of 0. It would be as if there were an x to the 0. The leading coefficient here is 8. So these are in standard form, and I told you the leading coefficient of each one. 4. We want to look at finding the sum of polynomials, and I'm going to show you 2 ways you can do it. I don't care which way you do it. You can choose whichever one makes more sense to you. The first way we're going to look at is a horizontal method. Remember, horizontal is like the horizon. So to do the horizontal method, we are going to group like terms. In other words, we're going to put the degrees together. I'm going to have 5x squared plus a negative 3x squared. Then we will have plus a negative 3x plus 6x. Remember, we're grouping like terms, same degree. When I say a like term, same degree, same variable, same degree. And then we would have plus 4 plus negative 3. So if we add 5x squared plus a negative 3x squared is 2x squared. Negative 3x plus 6 is 6x. And 4 plus negative 3 would give me just 1. So when we combine these two polynomials, we get 2x squared plus 3x plus 3x plus 1. Now, if we want to do this on the vertical method, some of you might prefer the vertical method. And I don't care which method you choose to use. But if we use the vertical method, I'm going to line them up vertically in standard form. Okay, and then we're going to add to 5x squared minus 3x plus 4 a negative 3x squared plus 6x minus 3. And then we have 4 minus 3, which is 1, negative 3 plus 6, which is 3x, and 5x squared minus 3x squared is 2x squared. Notice we got the same answer. It's just a matter of which way you prefer to do it. All right, here's another problem. Let's just first do it horizontally. I'm going to group like terms, 7y squared plus 5y squared plus 2y minus 4y, or plus a negative 4y. I'm just going to put minus 4y. I think we know what that means. Plus a negative 3 plus 2. Combine like terms and we get 12y squared. 2y minus 4y would be a minus 2y. And negative 3 plus 2 would give me a minus 1. So we get 12y squared minus 2y minus 1. If we do it vertically, put both of these in standard form, and we'd have 5y squared minus 4y plus 2. So if we add vertically, negative 3 plus 2 is negative 1. 2y minus 4y is negative 2y. And 7y squared plus 5y squared is 12y squared. Same answer. It's just your preference which way you would prefer to do that. Okay, let's look at this one. We're going to look at this one vertically. Notice that the first term is a trinomial, while the second term has 4 parts. So if we do this one vertically, we need to be sure that we make space for each term. So this is y to the 4th. Notice in the second one, I'm going to have a y cubed. So I'm going to have to hold a place. So I'll have a 0y cubed. And then we have a minus 3y plus 7. So now I have 4 terms in the first one. And then we're going to add to that 2y or minus 2y to the 4th plus 2y cubed plus 2y minus 11. I have to have a placeholder so that I've got something here for y cubed in that first term. So if we add, we're going to get 7 minus 11 is, okay, we get 7 minus 11 is negative 4. Negative 3y plus 2y is 1y. 0y cubed plus 2y cubed is 2y cubed. And y to the 4th minus 2y to the 4th would give me a negative y to the 4th. I wanted to work this one so that you would be sure and see that we have to hold a place right here when we add these two together. Okay, in these examples we're going to look at subtraction. And it's very similar to addition, of course. The first thing that we need to do is go through, and I'm going to use a different color, and let's change this to a plus, but distribute a negative through this second polynomial. So this becomes a plus. Negative 1 times negative 2 becomes a plus. This one becomes a negative, and this one becomes a plus. I would suggest you do that in a different color so that you can see. You're looking now at the green color. We've changed it to an addition problem, and the sign we're looking at is the sign that I have in green. Let me go back and change this back to white. So we've got 4x cubed plus 2x cubed plus negative 3x squared minus x squared. Notice I have just a 6x, so we can just put plus 6x. Then we have plus negative 4 plus 2. So if I combine each of these, we get 6x cubed minus 4x squared. Or you could put plus a negative and then just change it back to a minus. Plus 6x minus 2. And of course, you could also do this vertically if you want to do this vertically. But I'll just wait and do the next one vertically. Okay, so let's look at 8y minus 10 plus 5y squared minus 7 minus y cubed plus 12y. All right, now let's do this one vertically. I'm going to put the top one in standard form. Notice I'm going to have a y cubed, so I've got to have a 0y cubed here, plus 5y squared, plus 8y minus 10. And I'm going to subtract from that a negative y cubed. I don't have a y squared, so we can just put in a 0y squared, plus 12y plus 7. Now we're subtracting. I would highly recommend that you go through and change this to a plus and then change all these signs to the opposite. And now we can just add vertically. Negative 10 plus negative 7 is going to give us a negative 17. 8y plus a negative 12y gives us a negative 4y. 5y squared minus 0y squared is 5y squared. And 0y cubed plus y cubed is y cubed. If you would prefer to do that horizontally, you can do it horizontally. This is just a different method that you can look at. Let's do one more. Okay, let's look at this problem. I'm going to start by rewriting each of these in standard form, just so I don't skip something. Then we have 5n squared plus 4n minus 3. Now they're just in order, be a little bit easier to group them. Remember, the first thing we want to do is change this to a plus and take the opposite of everything inside. You're doing the distributive property, multiplying everything by negative 1. All right, so we've got negative 11n cubed and nothing to add to that, plus 6n squared plus a negative 5n squared. And then we have plus 2n plus a negative 4n plus 3. There's no constant in the first polynomial. So we have 11n cubed plus 6n minus n squared minus 5n squared is n squared. 2n minus 4n is a negative 2n plus 3. Again, if you want to do this in vertical form, you may do that in vertical form and add. You'll have to have a 0 in the first term to compensate for this negative 3 in the second term. All right, then, this is going to be assignment number 7. And it's on page 468. And you have 12 to 44 even. And for number 44, you will need to look at example 5 that is in your book on page 467. It's very easy to work. It's an application. But I believe if you can't figure out how to do it, then look at example 5 on page 467. Blessings to you.